Hello everyone, a very warm welcome to this video. In this video, we are going to talk about Spark. In the most simplistic terms, Spark is nothing but MapReduce that's 100 times faster. So you can look at Spark as a MapReduce replacement that can basically do everything 100 times faster. The crux of Spark is most of the stuff that Spark does is done in memory, and that makes Spark very, very fast. So now let's look at Spark. So let's talk about Spark. What is Spark in a single tweet, let's say? Spark is what you might think as, or what you might call as, Swiss Army knife of big data analytics tool. Now, if you really look at it, Spark has a complete stack that sits on top of Hadoop, and it can do any kind of processing, be it normal Spark, be it SQL processing, everything. So technically what you could visualize it is that entire framework of MapReduce that's out there is now replaced by Spark stack. So what exactly is Spark? Spark is fast and general engine for large scale data processing. It's just MapReduce which is 100 times faster. Advanced directed acyclic graphs. So basically what Spark does is it does not execute everything one by one, but basically creates an entire graph and executes the whole thing. The most important part as to why Spark is so popular is it heavily uses RAM, also has data locality, and it has support for both batch as well as streaming support. The biggest benefit of Spark is that you have rich APIs in Scala, Python, and Java. And it also has interactive shell where you can log into the shell and execute command one by one. Spark as a framework can run in standalone mode, that's on local file system. It can also run on Yarn, that's on Hadoop, or it has its own cluster that's called Mesos or Mesosphere. So here what we've seen is Spark, which is just a replacement for MapReduce, and that's 100 times faster than MapReduce. So let's look at a bit of history for Spark. Spark came out of AmpLab at UC Berkeley University in 2009. So in 2009, that was the first time Spark was created, and it was made a Apache top level project in 2014. So Spark is an independent Apache project, and it was created in 2014 as an independent project. It's backed by a commercial entity called Databricks. So you have Linux and you have Red Hat supporting it. Similarly, you have Spark, and Databricks is the company that's supporting Spark. Along with that, Spark is supported by Cloudera, Hortonworks, and MapR Hadoop vendors. It's a tool set for data analysts and scientists. What it really implements is RDD, Resilient Distributed Dataset. We'll be seeing that in some time. And yes, it works perfectly fine on Hadoop cluster. If you look at the trends, if you look at the interest around the community, if you see that Spark is one of the most active projects in the community right now. It's like the most attractive thing in the Hadoop community right now. So this is the community commits. You see that the amount of code that has got committed to Spark is massive, and it's one of the most popular project on GitHub also. When you look at the performance, you see a lot of benchmarks where Spark would easily prove to be 30 to 100 times faster than MapReduce, and that brings Hadoop to near real time. So every analysis that would typically take, let's say, 100 seconds in Hadoop over MapReduce could be done in a second in Spark, and that is the real power of Spark. Now, just like the way you have Hadoop, on top of it there are ecosystem projects. So the way you visualize it is you have HDFS, you have Yarn, Spark, and on top of Spark you have additional libraries like Spark SQL, streaming, machine learning, GraphX, and R, that's a data analyst or data scientist language. So what we've seen so far is Spark can sit on top of Hadoop, and it has its own ecosystem projects which are Spark SQL, streaming, mlib, graph, and Spark-R. Just to ensure that we clearly visualize it, let's look at how would Spark look like, or where would Spark really sit. So at the bottom of the whole game is HDFS. On top of it is Yarn. On top of that you will have a Spark core, then you have MapReduce, and on top of Spark you have other ecosystem components. HDFS, Yarn, Spark core, you have Spark SQL, which is SQL 100 times faster, you have machine learning, and you have Spark GraphX. So these are some of the libraries that are sitting on top of Spark. So let's see how does Spark really work. Now, in a normal programming language, let's just say you have a data structure called as array. Now, array can hold elements, but it's all on a single machine. So the unit of data in Spark is RDD, resilient distributed data set. You can visualize this as an array, but that is distributed across the machines. So let's say your HDFS file has 10,000 elements and there are 4 machines. You could visualize that this 10,000 elements are loaded in a memory and distributed across 4 machines. So RDD is basically, conceptually RDDs can roughly be viewed as partitioned, locality aware, distributed arrays or vectors. It's a read-only collection of objects spreads across the cluster, built through parallel transformations and actions. So when you have an RDD, which is like an array, which is a piece of data, so visualize this to be 20 machines, and you have an array of 1 million elements or 20 million elements. Each list will have 1 million elements, and that's distributed across the cluster, and they'll be processed independently. Now, when you look at a collection of 1 million elements, you can either have transformations on it or actions on it. Transformation means take this 1 million and create another set of RDD, and action means perform an action like count. So we'll see that ahead in the video. Now, why it's called resilient? Because if, for example, one of the machine is lost, we can recreate this RDD from the base data. That's why it's called resilient. It's distributed, it's a data set. So what exactly is a transformation? Transformation is an operation that takes one RDD and creates another RDD. RDD is nothing but you can visualize it as an array. So let's look at what are the few transformations. Let's say filter. So if I take one RDD where there are 1 million transactions, let's say I want to filter and bring out transactions that are more than $5,000. So that's an operation which is filter. So filter will take one RDD and generate another RDD. So these are some of the most common transformations: map, filter, flat map, map partition, and so on and so forth. These are some of the most common transformations. What are actions? When a transformation takes an RDD, it gives out another RDD, but when it comes to actions, actions will basically return a value, something like count. So count will take an RDD and give the element count of that particular RDD. So that's count. So actions are basically which give you that final output, or actions, their return type is a value, not another RDD. So these are the two types of operations possible on RDD. So RDD is an array. You can perform a transformation and create another array, for example, or you can perform an action on an array. So that will be an action. So count will be an action. So that's RDD. On a very high level, how it looks is, so let's look at this entire thing is a job. So this first outside bracket is basically a job. Now, each one of this is a stage. The state changes when the data has to move from one machine to another machine. So data was all here, and then it moves to another stage because it's going to another machine. In this case, data till it stays in a single machine, it's called as a complete stage. So you have a job till the data is in memory of a single machine, that's a stage. So there are two stages here, and then there is a final stage which is here. So that's called as stage. That's called as stage. All transformations in Spark are lazy. What does that mean? They are lazy because your Spark program will only get executed when an action is called. Assuming you're transforming a set of data for everything above $5,000, then something, and finally taking a count, till you hit the count statement, none of the statements will run. Only when an action is called, the entire program is executed. What is parallelism in Spark? You can define how many partitions of data could be made, and the developer has complete authority to decide it. So if I have 10 million elements, I can say I need 10 partitions. That would roughly mean that each partition will have 1 million records. I can say I need 100 partitions. That would mean that each partition will have 100k records. So partition is something that's completely controlled by the developer. It's completely controlled by the developer. Let's quickly look at a small example with Spark. So what we are trying to do here is we are first trying to load data in HDFS and then calculate the frequency of that particular words. So in the first case, we are saying that let's load a file in Spark from HDFS. So right now we've given a path. Now Spark is a framework that can read any data source, be it HDFS or local file system, or for that matter, it can read data from Cassandra also. So at the base, you have a data source that could be HDFS, and Spark is a framework that's sitting on top of it that could read the data for you, So first we are reading the data. Then we are saying map. Map means one record at a time. So now we've loaded all the data, which is one line is one record, and we are saying that each line convert that to lowercase. So what we do here is we get hello world, this is Spark, the end. And what we are doing in another RDD is bringing everything to a smaller case or bringing everything to a lower case. So right now we've called our first operation or first transformation on Spark, which is lowercase, but still the program is not going to run. Till you call an action, the program will not be running. In the next case, we say that, or I could have actually said instead of line to lowercase, we could also say underscore.to lowercase. This is as good as saying that each element should be converted to lowercase. So it's exactly same. Okay. So here we've converted everything to a lowercase in this particular function. Now what we do is we are splitting each and every record by word. So what we are saying is that if hello world is a sentence, split it as hello and world. This is Spark, the end. So what we are technically doing here is we are splitting each and every sentence based on strings. So now we have strings which are hello world, this is Spark, the end. You could visualize this as a multi-dimensional array. But if we want to convert this to a single dimension array, we would use something called as flat map. So in flat map, what happens is once you break a string and create a multi-dimensional array, flatten will create that as a single dimension array. So what we now get is hello world, this, end, and all the words one by one. So right now we've taken list of sentences, broken them based on strings, and we've flattened them as a single array. That is done. So here it is, the code for doing a flat map. Next, what we do is we want to count the frequency. So just like in MapReduce, you would prefix or suffix 1, we would simply say take each and every word and put it as 1. So hello 1, world 1, Spark 1, end 1. So that's how you get each and every word for you. So here we have all the words, just like end of mapper phase where we say word, comma 1, word, comma 1, word, comma 1. And that's a code for that. So this was all about the map phase of MapReduce programming. And later we call a function called as group by key. With group by key, what happens is, just like a MapReduce, this is a shuffle and sort or sort phase. Now here you get end, comma 1, hello, comma 1, Spark 1, 1, world 1. So everything comes together. This is as good as the shuffle and sort phase in MapReduce. So in the map phase we got word comma 1. In shuffle and sort phase we are getting the key comma all the values. We still haven't performed an operation. And later we add everything up. So later we add everything up and what we get is end 1, hello 1, spark 2 and so on so forth. So far what we've achieved is this is word count. Here we don't want word count, we want frequency of words. But here what we've done so far is word count. So far what we've done is word count. So here we've done reduce by key and you've achieved that. This was the code. Now let's say I want to get the top 10 words in this particular program. We have a function called as swap. Swap will basically make key as value and value as key. So with swap what you get is 1 comma and 1 comma hello, 2 comma spark and so on so forth. So this is the operation that is performed during swap. And finally when you do a sort by key you get top 10 words if you want or top n words for your program. So what we've seen is in around 7 lines we've done entire word count and sorted the words in such a way that word that's most popular will appear on top. So that's top n and that's reduce and this is how you get your top n. So what we've achieved is we've achieved let's say top 10 words in a set of documents and when you execute this program on a cluster you could have anywhere between 30 to 100 times faster output than MapReduce. That's a real core advantage of Spark. Spark could be easily 30 to 100 times faster than MapReduce and that's why in most of the projects now you would see that Spark is replacing MapReduce in a very big and prominent way. So just to reiterate the whole code, we first create a Spark context that's as good as a session and within that session we are first loading a file. We are converting each and every line to lowercase. We are breaking them to string and this is our end of map phase where we say word comma 1, word comma 1, word comma 1. Then we are doing a reduce by key that's summing. This is our reduce and then to find the top 10 words we are simply swapping it. This is how your top 10 words you would get in Spark. So let's quickly look at what are the other ecosystem projects that are building on top of Spark. So one of the project is Spark Streaming. Spark Streaming basically is there for real-time data. Let's say you get data from Twitter. Spark can basically bundle that tweets in a bunch of batches and let you process that particular data for that particular batch. That is what Spark does for you or Spark Streaming does for you. Spark SQL, it's a SQL layer on top of Spark, as good as Hive on Spark and could easily give you 30 to 100 times faster SQL performance than Hive. Graphics is a library that is there to find connections between the data. So let's say finding connections between people, one of the case that you would do in Spark is that. Machine learning, stuff like collaborative filtering, classification and so on so forth, which we've already will be seeing that in videos, can be done in Spark. Who's using Spark? Yahoo is using Spark in a very big way for its ad networks. Yahoo mobile ads, they basically get served with the help of Spark. So they really make use of Spark in a very heavy way. So what is future for Spark? Now Spark is successfully sitting on top of Hadoop. So that's Spark on Yarn and there are a lot of implementations that will come in and a lot of enhancements that will continue happening. That's the goal of Spark. Okay. So future work is there is a lot of focus on Spark maturity, enable long running services, giving resources back to the cluster when idle. That is something Spark is working on. So better resource management and focus on adding capabilities to the Spark ecosystem. So that's what is Spark all about. So in a very simplistic terms, Spark is an execution engine that's just like MapReduce, or you could visualize it as a replacement of MapReduce that could work 30 to 100 times faster than MapReduce. That was Spark. Thanks for watching this video, and see you in the next video.